Welcome to this lecture series in coordinate geometry in straight lines. In this lecture, we'll be looking at the coordinate formula for the area of a triangle and some applications of it. And let us get started. All we need is to know what is meant by the coordinates of a point. It's as basic as that. So a coordinate, so once we have the coordinate plane, which just means that we have drawn two perpendicular lines on the Euclidean plane, the usual plane, then any point on the plane gets assigned an address which consists of two numbers, and those two numbers are obtained by dropping a perpendicular on the horizontal one, taking the whatever assigned distance that you get, putting it here, and dropping a perpendicular on the vertical one and taking the assigned distance from the origin and putting it there. So that is what is meant by the coordinates of a point. Here are some problems for practice. And now let us get started. So we will need to recall something that we know from basic geometry, which is the formula for the area of a trapezium. So suppose I have been given a trapezium, which just means that two of the sides of this quadrilateral are parallel. So here in this figure, AB is parallel to CD, and suppose H is the distance between the two parallel lines. So we want to express the area of this trapezium in terms of, let's say the lengths of AB and CD and H. So what is that area? The area is half of H times the length of AB plus the length of CD. That's the formula, and the reason for this is very simple. Let me just give a proof. So what this says is that this is equal to half AB times H, let me write it that way, plus half CD times H. And so what is this quantity? Just draw a line here. So let me just draw this line, and maybe it's white color is better. So consider this triangle, and think of this as the base of the triangle. So the height would then be H, because this is equal to that, and the base is this. So the area of triangle ABD is half times AB times H. And the area of triangle DBC, by the same reasoning, if you think of this as the base, is half of CD times H. And the sum of these two areas is the total area, and that's it. So this is a formula that we know. And now suppose we are given a triangle ABC whose coordinates, the vertices have coordinates x1, y1, x2, y2, and x3, y3. Then we want to find the area of the triangle ABC in terms of these six numbers. So we will prove this, and let me make a simplifying assumption. So we will assume in the proof, that first of all, everything is positive. So all of these six numbers are positive. And we will also assume that this is the case. This just helps write the proof easily. The formula will be completely general. The formula does not require any such assumptions, the final formula that we will write down. But we'll do the proof only in this special assumption, and you can figure out what happens if these assumptions were not made. This is really nothing. This is basically a result of translation. If you translate this triangle suitably, then you can always arrange this, and whatever formula we are going to get, you will see is invariant under translations, as it should be. And this is just a matter of playing around with different orderings. So let me just write the proof in this special case. So what we will do is we will make a certain construction. So drop a perpendicular from A to the x-axis, call the base x, call the foot of the perpendicular x, not the base, the foot of the perpendicular from B, and then the foot of the perpendicular from C. This is called y, this is called z. Okay, and now we have what we observe is that the area of triangle ABC, which I denote by this notation. So we make a bracket and put ABC inside, and this is supposed to mean the area of triangle ABC. So this is nothing but, one can easily see, the area of the quadrilateral AXY y, or let me write it as ABYX plus the area of the quadrilateral BCZY minus the area of the quadrilateral ACZX. So this quadrilateral plus that quadrilateral minus that much, because this is not part of the triangle. So that's clear, and each of these are trapeziums because these three lines are parallel, all of them being perpendicular to the x-axis. So those three lines are parallel, and therefore each of these are trapeziums. So what is the first term? So the area of this quadrilateral ABYX is half of, so this is the height because these two are parallel. So if you correspond with the previous slide, this becomes the height. So the height is x2 minus x1, right? Because basically it's the difference of the abscissas of, okay, so you want to find this length. What are the coordinates of y? It's x2 comma 0. What are the coordinates of x? It's x1 comma 0, and therefore this is x2 minus x1. So this is half of x2 minus x1 times the average of ax plus, I mean, it's half of x2 minus x1 plus the sum of ax and by, which is half of x2 minus x1 y1 plus y2. Similarly, the area of BCZY is half of x3 minus x2 times y3 plus y2, and the area of the third one, ACZX, is half of x3 minus x1 times y3 plus y1. Okay, and now if we substitute these expressions, what we have computed, so this is equal to that, and this and that, here we will get the final answer. It's just a matter of algebra that the area of triangle ABC is half of x1 times this plus x2 times x3 times y1 minus y2. Let me check if I'm writing the correct thing. x1 times y2 minus y3, x2 times y3 minus y1, x3 times y1 minus y2. Yes, this is what you will get. So the final answer is this. The area of the triangle ABC is half of absolute value of the expression at the end. So why absolute values? This just takes care of every possible case. That's all. Because you might get a negative answer if you do not have this assumption and you use this formula. This might be a negative number if this ordering was not assumed. So to account for all those cases, just an absolute value does the job. So that is just some matter of computation. I'm not going to do it. So that's the formula for the area of any given triangle. Once you know the coordinates of the vertices, you can write down this very neat formula and find the area. Okay. Here is a simple example, a special case. So our triangle is such that one vertex is at the origin. So let's say these three are the vertices and A is at the origin. So what is the area of this triangle? This is half of absolute value of x1, which is the coordinate of A, times y2 minus y3. Well, there was a 0 here, so I didn't need to bother, but anyway. And then we have x2 times y3 minus y1 plus x3 times y1 minus y2. Hopefully I did not make a mistake. This is equal to half CB minus AD, which I will write as half of AD minus BC. Easiest to remember. And you don't need to remember this, but anyway. So the area of this triangle is half of AD minus BC, and you could have also found this out by using cross product. So if you know vectors, then you could just take the cross product of these two vectors and take half of that or something, and you will get this same thing. But anyway, this is a course on coordinate geometry. All right, here is another example. So for what values of x are these 3 points collinear? So when we say 3 points are collinear, we just mean that all the 3 points lie on a single line, meaning there exists a line which passes through all 3 of them. So what are all the x's for which these 3 are collinear? So let's say, just to explain the thing, 1 comma 5 is somewhere here, 4 comma 11 is somewhere here, and x comma 1 is maybe somewhere here. So just note that these 3 points are collinear if and only if the area of this triangle is 0. That's an if and only if condition. So what are we being really asked is what are all the values of x for which these 3 vertices form a triangle whose area is 0. So basically they form a degenerate triangle. And to do that, we just write down the formula for the area, which is half of absolute value of x1 times, so let's say this is a, so x1 y1 is 1 comma 5, this is b, maybe this is b, and this is c. So x1 y1, x2 y2, x3 y3, and now let us write down the formula. So x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2, and this we want to be 0, which just implies that the absolute value of minus 10 plus, or rather plus 6x plus 16 is 0, which means absolute value of 6x plus 6 is 0, which implies x equals minus 1, which is probably fine, because all you need to do is it's fine, this is our answer, but geometrically what we are asking is just draw this vertical line, or rather not the vertical line, draw this horizontal line, meaning the line where all the points have ordinate equal 1, and where does it intersect this line? So geometrically that is the point we were after, and it turns out it is this point. All right, so this the formula for the area detects collinearity of points also, for a very simple reason, and this was an illustration of it. All right, so as usual, like, comment, share, subscribe, and I'll see you next time.